Thank you very much for your kind introduction. I would like to start on a sadder note. I would like, because I think the earthquake that happened in China is a tragedy, and I would like to express, of course, my sympathy for the victims of the earthquake, and also for any of you who may have family or relatives in that region. I really hope they're safe. This is, of course, very, very difficult in any country. We have earthquakes in California also, and we have not had actually an earthquake as major as the one in Sichuan, but they fear that such an earthquake will happen in the next 10 or 20 years. So we feel very much for, the Chinese people, and in particular the people in Sichuan right now who have to deal with the aftermath of the earthquake. Okay, well, so this morning I I will endeavor to talk about the origins of language and thought. And ever since humans can speak, they have wondered where language originated. And there have always been a lot of speculations, and I'm sure that since you are linguists, you know about the legends where, for example, where children were brought up in a cave or something, and then without any environment, and then they would listen to the first syllable of the child or the first word, and they would say, oh, that's in this language or that language, therefore that was the first language. Okay, these were early speculations about the origins of language and what was the first language, and linguists have always done that. In fact, things got so bad in the 19th century, there were so many people speculating about the origins of language, that I believe the Society of Linguistics in Paris, in France, where I come from, they decided to forbid any more papers on the origins of language. Nobody was allowed to present papers on the origins of language because there were too many and they were too speculative, and they had all kinds of very strange, very crazy ideas. Now, suddenly, in the 21st century, there is a renewed interest in the issue of the origins of language and thought. And so, once again, there are many, many publications on this topic. Mark Turner and I worked on conceptual blending and conceptual mappings together, and out of our work, unexpectedly, came some, possible results regarding the origins of language, regarding this problem. And so we have a chapter in our book, in The Way We Think, we have a chapter on this topic, and also there is a book which just came out at Equinox Edition, and it has a collection of articles on this topic. So we will, again, revive speculation about origins of language and thought. One of the reasons that in this modern period there is this renewed interest is because there have been both archaeological discoveries that are quite interesting, and there have been biological discoveries, discoveries in the domain of genetics, okay, that suggest a more clear pictures about when humans, with not only our anatomical properties, but also with our cognitive abilities, when these humans may have originated. And I'm certainly not a specialist directly of these issues, but this morning I will try to show how some of these issues in biology and archaeology seem to fit together nicely with some of the results we have from linguistics and cognitive science. Okay? So, very briefly, for some of you who, of course, were not at the other lectures, I will give a very short, with apologies to those who have heard this before, I will give a very short reminder of some of the issues that we have been talking about, and also the spirit in which cognitive linguistics in general approaches such issues. These are the useful websites. If you want to find out more, get some articles. There's a specific website on the Beijing Forum within the Mental Space website. So again, a good source for all kinds of readings. On the Beijing Forum website, we've actually put many, I have put many articles that are directly accessible in PDF format. So again, this may be convenient. This is these are some of the books that have recently appeared specifically on the topic of conceptual blending, which is the organizing framework here for the lectures I've been giving in Beijing. And these books are very varied. Some are on linguistics, but others are on topics as different as music, design, artificial intelligence, art, religion and magic, and so on. And they have all taken as an organizing framework the framework of conceptual mappings that was initially proposed within cognitive linguistics. You will find information on all this literature at the websites that I just mentioned before. The spirit of the Beijing lectures, in harmony with cognitive linguistics in general, has these sort of 4 fundamental points that I have been evoking almost at every lecture. And the 4 points, for those, again, who are joining us today for the first time, the 4 fundamental points are that language is only the tip of the iceberg of meaning construction. So a lot is going on behind the scenes. Most of it is going on behind the scenes. And language, therefore, does not directly map to meaning, but rather triggers and guides meaning construction of a much more elaborate sort than the grammatical structures that we explicitly see and are conscious of. The second point is that the meaning construction that is fundamental for language is also operating in many other areas with the same cognitive operations, operating in mathematics, religion, technology, poetry, and so on. The third point, the conceptual mappings are the same for these superficially different areas of human thought. And the consequence for linguistics is that linguistics can have rich interaction with other areas, both in the sense of feeding ideas, because understanding some of these operations of the mind and making them applicable to areas like music or mathematics. And this is, in fact, exactly what has happened. So we have, linguists like my friend George Lakoff or myself doing work on mathematics, for example, by using the ideas that were originally developed in cognitive linguistics. Conversely, it is very important for linguists not to lock themselves up in a language box and look only at language. Linguists, in the spirit of cognitive linguistics, need to look at meaning construction in other domains, because in some of these domains, the meaning construction operations are more apparent, are easier to find, but they apply in return to linguistic problems. So those are our sort of fundamental 4 working framing hypotheses, with the idea, again, that hidden behind the simple words are vast conceptual networks in your head that you're not always aware of, but that as a linguist you try to be aware of. You try to go inside your own head and ask, what is going on in my head when I talk? Okay. We have used then, in the previous lectures, we have used this framework of conceptual integration, where the sort of most simple basic schema is a schema of 2 inputs that share some common structure in this, indicated in this generic space, and that project to a novel blended space where emergent structure is created in a number of ways. And that's where we get the power of novel meaning construction, both in everyday life, but also in creative activities of art, science, mathematics, and religion. So these are some of the principles that we have been talking about, and I will evoke them also throughout this lecture. And again, for those who were not with us in the early lectures, I will give a sort of straightforward example proposed by my colleague Shana Coulson, and this is the example of trash can basketball that we have not used yet in other lectures, but it's a very transparent example of what blending is about. And here is the story about this. We all know the game of basketball, of course, you know, and throwing the ball into the hoop and having two teams trying to score points. Now, imagine a second situation, not on the basketball court, but where you have students in a dormitory, and they don't have a ball, but they have a trash can, a waste paper basket. And they also have paper that they can crumple. And they start to play a game which is to throw the crumpled paper into the trash can. And of course, as they do this, then rules emerge and they start to play against each other. And you can see that the game is, in some ways, like basketball. You have to throw something into something else. But in other ways, it's quite different. Instead of the hoop being up there, the trash can is down here. Instead of a ball, you have a light crumpled paper. Instead of a basketball court, you have to run around the beds in the dormitory, and so on. So the new game, the trash can basketball game, is an emergent human activity here, which is the result of blending two different inputs. One input is the game of basketball, where you have things like the basket and the ball and, of course, many other things. And on the other side, you've got things in your room that are not part of games. Paper, crumpled paper, trash cans, and so on. And you map the trash can onto the basket, and you map the crumpled paper onto the ball, okay? And then you project, and now you have a new blended mental space in which you have a ball, and you also have a basket, but the basket is the trash can, and the ball, of course, is the crumpled paper. And within this blended space will emerge a certain type of game. People will, of course, add rules, and they'll decide, you know, what counts as 1 point, 2 points, and so on. And there will be an emergent game here. This game will be quite different from that one. But, so these two inputs are different. I'm sorry, this input is different from the blended space, but the blended space has the same objects as the input of paper and waste paper baskets, but it is very different because it is organized as a game structure coming from here. Okay? So this gives a pretty good idea of how humans very easily and naturally can take two inputs that they're very familiar with, both, you know, paper and trash cans and basketball game, and they can create new activities that have emergent structure, different. The crucial thing is the structure here is different from the structure in either one of the inputs, and that's the characteristic fundamental property of conceptual blending. Now, once you have blends like that, you can enrich them. And in the lectures on metaphor, we saw how the fundamental, already sort of very complex, but mentally entrenched structure of metaphors of time, for example, we saw how they could be additionally blended with other inputs to create more novel metaphors, literary metaphors, and so on. So here is a not very literary, but this is from a comic strip, and this is, so it's a cartoon from a newspaper. And this is a case where they don't know about Shauna Colson's trash can basketball, but they independently invented it. And they made another blend with the famous basketball player, American basketball player, Shaq O'Neal. I don't know if that's a name. Do some of you know this name, basketball player? He's a very, very big. He's not as tall as Yao Ming, but he's very heavy and big. But Shaq O'Neal is a very good basketball player, except that he's not very good at making the free throws. You know, when you stand in front of the basket after a foul and you have to throw the ball into the basket, that's one of his weaknesses, that he's not good at that. So in the cartoon, they say, here is the way the world would be if Shaq O'Neal, instead of being a basketball player, if he was an office worker, if he had a 9-to-5 office job. And what you see is that in his office job, he tries to throw the crumpled paper into the trash can, but he's always missing. He's always missing the trash can. So what they did here in the cartoon is they blended basketball, Shaq O'Neal with his weakness in the free throw, and they blended that with the idea of an office worker who throws paper into a trash can. And the difference is that if you just throw things into a trash can, you throw to get rid of them. But this office worker has made it into a sort of game, trying to put the crumpled paper into the waste paper basket. So, again, an opportunistic example of how you can use blend and then other blends in order, for example, in this case, to produce humor. Humor is heavily dependent on blends. You can also see, even with this example, that linguistically, there are a few little things happening linguistically. There is a word, trash can basketball, that is invented in order to describe the new emergent game. And it's a two-word grammatical construction, noun, noun. In the lecture number 6, we talked a lot about grammatical constructions and these noun-noun combinations. And we had examples like land yacht and jailbait. If you have the complete handout, you'll find them at the end of lecture 6. Now, here's a case. From one input, you take one word, basketball. In this case, it's the description of the entire input, in fact. And from the other input, you take one word, which is one of the objects, trash can, the one that is going to correspond, the one that is going to be mapped to the basket, okay? And so the linguistic way of referring to a novel emergent structure here is to take one word from one input and another word from the other input, not necessarily matching words. But in this case, the name for the whole game happens to contain already, you see, this name itself is already a blend. The name basketball is taking two crucial objects in the game, basket and ball, putting them together and giving you the game of basketball. But then you put it together with trash can and you get the new game of throwing the crumpled paper into the trash cans. Okay? Okay, so this is what the blending network looks like. You have a generic structure, meaning something that is common to both inputs, something round and a container, something round that you can put in a container. And in this input, you've got the game of basketball. In this input, you've got the trash can and crumpled paper. Okay. Now, another thing that we have not talked about in the previous lectures, it was evoked in some of the question periods, but it's probably relevant to this morning's issue of the origins of language, is when we look at these conceptual blends, we find that there are different types of conceptual blends, and they sort of appear on a gradient of complexity. You have some that are intuitively more simple, and others that are more complex. So very quickly, here are examples of these varieties of blends. One we call the simplex network, and that one is actually very close to what people have traditionally called framing. So what it does is it takes one input with no frame, like Paul and Sally, and it takes another input that is only a frame. Like in this case, it's the kinship frame with father and ego, okay, and maybe other family members, you know, the mother and the siblings and so on. But the important ones are the father and ego for this particular blend. So a frame on the one hand and two elements on the other. And we map them onto each other and we project into the blended space. And now we have a frame with roles that are filled. So the roles, father and daughter, are filled by Paul and Sally. This is the space in which Paul and Sally are father and daughter. Okay? A very straightforward, apparently, kind of framing. There are some additional interesting emergent properties that I will save maybe for later. But this kind of simplex network is actually something that other species seem to be able to do. So chimpanzees and also very certainly dogs and cats and probably elephants and so on, many mammals, maybe all mammals, can do this kind of blending. They can learn specific frames about things and they can apply the frames to given situations. So this is not a kind of blending that distinguishes humans from other species. Now, here's a second kind of blending, a little more complex, that we have studied. This is a case where the two inputs have frames, and they have a similar frame, almost the same frame, the same organizing frame. And we had several examples of that. I will not review them, but I'll just remind you. One example was the boat race, the regatta, the catamaran, sailing, and after the Clipper sailed 1 century earlier. And there was a blended space in which the sailboat now and the sailboat, the Clipper, many, many decades earlier, were blended so that they could be in a race. Now, that network has two inputs that have the same frame, sailing from San Francisco to Boston. So they are called, if they have the same frame, they're called mirror networks. The example with debate with Kant, that again, if you were not at the early lectures, you will find all this in the readings on the web, okay? So these are well-known examples. The debate with Kant also had the same frame in both inputs. It was the frame of a thinker who was thinking in some language and who had a purpose and who had some issues that he or she was thinking about. So these are mirror networks. I don't know. There have not been, so far, the right kind of evidence of experiments to know whether chimpanzees, for example, have the capacity to do mirror networks. That's an open question. Okay? We're not sure. It may be, well, again, I'll come back to that. Okay. This example was also a mirror network. There were 6 inputs in that case, and those were the 6 inputs of the 6 races where the world record was broken, and they were all blended into a single race with all the former world champions on the same track. Again, mirror network because all the 6 inputs have the same frame. Okay, now a slightly more advanced, it seems, type of network is the single scope network. The single scope network has 2 input spaces that don't have the same frame, that have very different frames, and then they project into a blended space using the frame of the first input, but using the elements of the second input. And here's an example of that. If you have two men boxing, that's the input, two boxers. Okay, that's the framing input. And now suppose that you talk about financial leaders, CEOs, you know, chief, whatever that means, chief executive officers of companies, CEOs in business. And suppose they have a business competition. So suppose it's the Iacocca, who used to be the head of Chrysler, and Murdoch, who controls many newspapers. Suppose they have a competition. We can describe the competition in terms of boxing. Okay? That's typical metaphor, of course. And we can say that one of the competing financiers or CEOs landed a blow. That's a boxing blow. And the other recovered. But one of them tripped, okay, falling. The other took advantage and knocked him out. All these, in italics, all these are boxing terms. And what is going on here, again, is a conceptual blend where one input is the input of boxing, and the other input is the business input with Murdoch, Iacocca, you know, financial deals and so on. And in the blended input, you've got the Murdoch is a boxer and Iacocca is a boxer, and they're fighting, but they're also financial competitors in the blend. So that's the important thing, of course, where you can project back here. Now, the important thing then for the single scope network is that the frame here is entirely transferred to the blended space. The blended space does not use the business frame. So, actually, single scope blends are, again, very much like the traditional source-target metaphor. The source-target metaphor in sort of standard metaphor theory, as in Lakoff and Johnson, is a case of single-scope blends. You have a source domain, you have a target domain. The source domain projects to the target domain, so this is the result. This is the source domain projected to the target domain and organizing the target domain with its frame. Again, it is unlikely but possible that some primates have single-scope blending. It is conceivable that, for example, the chimpanzees like Sarah, who learned to operate with chips in order to little, you know, blue, yellow, colored chips, in order to refer to frames, it may be that that's a case of single scope. So advanced primates may well have the capacity for single scope blending. Again, we need more experiments for that. We know humans, of course, have all these capacities. Finally, the type of blending that is, in a way, most creative and most important for the development of the purely human activities is the so-called double-scope blending, where you have two inputs with very different frames, but the blended space is projecting from both inputs, not just one frame from one input, but the two frames from both inputs are making a contribution. So, in previous lectures, we used examples like this one. This is the advertisement for children to improve the education of children. And the children are blended with doctors, the idea being that if the children have a bad education, then 20 years later they will be bad doctors, and when they perform operations on you, you will die. So in this advertisement, the two very different frames are blended, the frame of children studying and the frame of doctors operating. And suddenly you have a single here frame. You have the children learning and also the doctors operating. They're blended into one frame. So that's a case of double scope blending with these two inputs coming into one. Another case that we mentioned several times in the other lectures is the case of double scope metaphors. Many, many metaphors are double scope also. That is, they draw from both inputs. And so they require blending. You cannot do them with simple source-target projection as in the early metaphor theory of Lakoff-Johnson. You need to account for them with financial blending. And the way that works, the reason for that, in a nutshell, with a new diagram that I found someplace, this will maybe explain why the traditional metaphor analysis will not work here. Because if you look at the source domain of digging graves is that you have two people here, the digger and the dead person, and it's when somebody dies that you later dig the grave. So the death is both the cause of the digging and also it precedes the digging as an event. But the so-called target domain is organized quite differently. There is only one person. It's the same person who is making the financial mistakes and who will eventually fail in the business endeavor. And moreover, the element here that corresponds to digging, making mistakes, is actually oriented towards failure, the element corresponding to death. It's oriented in the opposite direction from here. It's because you make mistakes that you have failure. So the cause goes this way, and also the events are ordered in time. This happens before this. Okay? So those two have very different structures. In traditional source-target metaphor, if you project this structure, you get a wrong structure here. You don't get this structure. Okay? So the two do not fit. This would be a bad metaphor if you just had source to target. But in fact, in terms of conceptual blending, it becomes an excellent metaphor because you can project some of this to the blended space, the digging and the death and the digger and so on. But you can project all the event structure and frame structure of the agents, you can project from here so that you have a single digger and dead person. You have an action of digging that precedes death. The more you dig, the closer you are to being dead. Okay? So I think, again, this diagram sort of brings out visually, very vividly, that in order to get the right metaphorical blend here, you need to project from the two frames, okay? Not just a single one. And that's where the power of double scope blending comes from. And we saw other examples in previous lectures, like this example. If the Clinton were the Titanic, the iceberg would sink, where again, two very different inputs. They're structured in a different way, and in the blended space does not have the same structure as the source domain of the Titanic and the iceberg. We also used, and again, this is quickly for the people just joining us today, we also looked at some important counterfactual examples where you can build a counterfactual like this. This is a case where the young man murdered his grandparents, and yet the father is pleading for mercy and saying if the grandparents were still alive, they would plead for mercy for their grandson because they love the grandson. And so this is again a case where you are blending two completely incompatible spaces. The one where there's been a murder and the grandparents are dead, and the other space where the grandparents are alive and they love the grandson and they want to help the grandson. And in the blended space, all this comes together. The murdered grandparents become alive in order to save the grandson who's being sentenced by the judge. Okay? So humans have, as part of their double scope capacity, they have this very, very important, powerful capacity to build counterfactuals. And counterfactuals and metaphor both play a big, big role in the development of science. Okay? It's through successive metaphors and counterfactuals that you can build scientific experimentation, that you advance physics, that you advance mathematics, and so on. So those are crucial. As, again, primates, chimpanzees, who are, of course, very advanced in many respects, do not have double scope blending. They do not have counterfactual ability, building counterfactuals. They do not build double scope metaphors. So all that is very specifically human. And in one of the previous lectures, number 4, I think, we also illustrated this with cases from mathematics. In the lecture yesterday, was that yesterday? No, I guess it was on Sunday, lecture on grammatical constructions, we showed that grammatical constructions in general, and we took examples like Gogol sneezed the napkin off the table, or the sergeant let the tanks into the compound, and we showed that grammatical construction in general was a blending of simple syntactic structures with minimal meaning and complex meanings on the other hand, complex causative meanings, and they get blended so that in the blend you keep a simple syntactic structure, but you are able to reconstruct a more elaborate, more complex meaning. Okay? So this means we have examples now of many, many things that are double scope blends and that are needed for language, metaphor, grammatical constructions, counterfactuals, that are also needed for mathematics and science, that are also needed in order to produce art and religion, as I will show in just a minute. Now, the examples that you've got here, they show that even the same word, the word father, can be used on a gradient within this hierarchy of conceptual networks, the simplex, the mirror network, the single scope, and the double scope. So if you look at these examples, Paul is the father of Sally. This is the simplex network. It's just framing. Paul and Sally go into the ordinary father and daughter frame. This one, Zeus is the father of Athena. She was born out of his head. This is also a father-daughter kinship, but it comes in with additional blended structure, where instead of coming out of the womb of the mother, Athena can now come out of the head of the father Zeus. Okay? So it's an unusual kind of procreation, but again, within the kinship system. The next one, somebody who says, you have a child and you're busy that day, and so you ask your friend, your neighbor, to take care of the child, to take him to school, go and get him at school and take care of him. The neighbor can say, I'm your father for today. I'm your father for today. And in other words, the word father here gets extended by building a blended space in which father means not quite the biological and genealogical father, but the nurturing father. Remember George Lakoff's examples in Women, Fire, and Dangerous Things, his examples about the word mother and the radial categories. Well, this is how radial categories actually get formed. You extend from father and you get other meanings. Then the Pope is the father of all Catholics. The Pope is the father of the Catholic Church. These become, as you can see, more and more metaphorical. The Pope is not, of course, the biological father, but again, he takes care. And there's a symbolic religious sense in which he is in a father-child relationship to the faithful. When we get here, we have a similar thing. George Washington is the father of our country, but in a different way. Father here emphasizes the causal elements, that George Washington was the founder, and from him came the country of the United States in this case. So he's no longer, the Pope is around to take care of us, maybe. And George Washington is not around anymore, he's dead, but he's the father of our country in a causal sense now. So all of these, if you analyze the blends, you will find that they work by using different selective projection. From the input of father, you project only certain things in each one of these kinds of examples. Newton is the father of physics, becomes even more abstract and causal. And here we have, this is from a poet, Ezra Pound, we have fear, father of cruelty, even more abstract and metaphorical. Now it's emotions and human characteristics like fear and cruelty that are projected to father and so on, with, of course, again, emphasis on the causal connection. Okay? So when we get to here, we have very clear double scope blends. Okay? Up here we have simplex. And in between, we could argue that we have somewhat mirror blends, the same frame organizing both, but with different properties in the blended space. So the same word can be used on the whole gradient of conceptual networks. The last example here is from also the poet Wordsworth. The child is father of the man. And that's a sort of spectacular double scope where the literal meaning seems to be contradictory. How can the child be the father of the man? And of course, what this one means, again, emphasizing the causal relation, is that the way you are as a child, the way you're brought up, educated, the way you behave, the way you learn certain habits and how to do things, will determine what kind of man you will be. So child and man here are actually identical, even though they're very different. This is the mental space connection of identity, the same identical child and man, but the child is causing the type of man. So the creativity here is obvious, and it's double scope. How does all this connect to the problem of the origins of thought and language? Well, when we look at, in this case, the evolution of life on Earth from, early whatever it is, bacteria, cockroaches, and so on, we find 3.5 billion years. And as we go on and on, right here we find the dinosaurs, okay? Maybe it's the extinction of the dinosaurs in this little red part. So you can see even the dinosaurs don't have a big long time on Earth if we look at this diagram. And then over here we have a very tiny point actually that would be the present kind of human being. The present kind of human being, there are reasons to think that they have not been on Earth more than about 50,000 years. Now, it could be 35,000, it could be 65,000. Okay? It's not important. It's still a very, very small, very small point on the entire evolution of life on Earth. But also, if you look at mammals, mammals again have only a short span over here, and the humans under 100,000 years is a very, very short span. Now, what is it that makes us think that it's less than 100,000, probably about 50,000? Well, there are two types of work. There's work by archaeologists that's quite interesting, and they find the cave paintings like the Grotte Chauvet in France, which is one of the famous caves, and you have these lions. The drawings, very, very striking, powerful art on the cave walls of the lions. Here's some other cave paintings with, this time it's some kind of some kind of buffalo or similar animal, bison. Okay. This is a human hand found in the Grotte Chauvet. This is a kind of leopard, and on and on. Now, what is striking about these cave wall paintings is that they are extremely good. It's not like they had childish, paintings, and then later we find evidence for people learning to paint better and better. No, the very first evidence of human art is excellent art. Very powerful and very good art. And this art, there's reason to think it was used for religious purposes. For example, the animals on cave walls were probably, some of them anyway, were probably considered to be a way to accessing spirits. Spirits who had a double personality, that they were part animal and partly sort of like humans, able to think, to talk, and so on, but of course more powerful than humans. So religions depend on, in this case, on being able to blend animal features with human features. This is a strong double scope blend. This has been noticed by another archaeologist, Stephen Mithen, who says, in order to get religious practices, in order to get modern human thinking, you have to have the possibility of cognitive fluidity, which is the ability to do double scope blending between very different inputs. So it looks like, in the case of art here, before about 40,000 years ago, no evidence of art anywhere. Suddenly, evidence of art in different caves around the world. And the art is already sophisticated, and the art is presumably being used for religious purposes. Also, the same with tools. You find that under the Neanderthal, for example, you find the same tool being reproduced over and over again, and no interesting creativity of tools. Starting in, again, around 50,000 years, suddenly there's a wide variety of, prehistoric tools. Okay, this is more of the, again, the diagram showing the Homo sapiens up here, about maybe between 100 and 200,000 years. But as archaeologists now, Klein, and biologists have shown, there are two kinds of anatomically modern human beings that came from Africa, that have the same anatomy and the same that we do. And that's, probably about 200,000 years old out of Africa. But there is a cognitively modern species that comes out of Africa much later. That is only about 50,000 years ago. So this is argued by the famous archaeologist Klein, but it's also argued, interestingly, by geneticists who have studied DNA, and in their study of DNA, they've been able to corroborate the fact that there would be a common African ancestor for us that would be about, again, 50,000 years. So even though the anatomically similar species is older, the cognitively similar would presumably be about 50,000 years old, coming from a single woman ancestor in Africa. Very interesting. This is more on your handout. I think I've copied a lot of that. And what these geneticists end up with, Cavalli Sforza is another one with this, who has found the same result. And Cavalli Sforza ends up actually bringing the origin of language to about, again, 50,000 years. So we have now religion, art, language, and tool-making technology, and they would all seem to be born at about the same time, the 50,000 years, and that would be the time that this cognitively modern human ancestor would arise. So, what next? Well, informally, what all this suggests is that because to do religion you need the cognitive fluidity of double scope blending, in order to make the new tools, the new technology, you have to blend certain kinds of tools with others mentally in order to get new ideas. And of course, in order to get language, you have to have all the double scope blending that I mentioned at first. It suggests then that the human beings before the cognitively modern ones did not have double scope blending, and the ones after that did have double scope blending. Okay? So that's one idea, that double scope blending is really something recent in the history of mankind. Okay, now how does that bear on the theoretical issue of the origin of language? Well, let's look quickly at some other theories, okay, before we go back to our theory. Some other theories, here's one popular theory, a nativist theory, with Chomsky as one of the main proponents of this theory. And the Chomsky idea is language is so different from anything else, there must have been a sort of biological event that happened in order to make language possible. So there's a language organ in the brain that is different from everything else in the brain and makes language possible. That's the nativist view, but then it poses the problem of, in evolutionary terms, in terms of Darwin evolution, how could something so sudden happen? In evolution, mutations happen very slowly, very, very, very slowly. So how could you suddenly have one day nothing for language and suddenly the next day everything for language? That sounds very, very strange. So other researchers like Pinker and Bloom, they say there must have been previous steps. There must have been simpler languages maybe before. The trouble with that hypothesis is that there is no evidence for them, just like there is no evidence for early forms of art. Drawings on caves that would be sticks and circles instead of being fully elaborated lions and tigers. So there's no evidence for the intermediate aspects. Another kind of theory says the brain is a statistical machine that gets better and better. But again, why then would there not be intermediate steps? So it runs into the same problems. Well, from our point of view, that is me and Mark Turner doing this work, we think that the other proposals fall prey, are victims of two fallacies. One is the cause-effect isomorphism fallacy, which consists in thinking that if you have a sudden effect, if you have something very different, there must have been a correspondingly sudden event, a big catastrophic-like event if you produce a catastrophic effect. Now this is a fallacy because in fact many things in the world are continuous, very gradual, and then at some point, even though they're very gradual, they suddenly produce a big effect. The examples of that are all over the place. For example, suppose you have your bathtub and the water does not turn off completely, so that there are drops of water that drip into the bathtub. Drip, 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 drip. All night long. The bathtub slowly fills up, right? And it's all continuous, one drop at a time, and the change at every point is hardly noticeable. It's the level of water in the bathtub. It takes a long time to go up. But suddenly, there must be one last drop that's suddenly, too much water. And when that drop happens, you don't just get one drop falling out of the bathtub. You suddenly get the bathtub overflowing, and you get a lot of water that comes out of the bathtub. So here's a case where a very continuous, minute set of events will suddenly produce a catastrophic event. And the second fallacy is the idea that when you have a function, you must have an organ for it. So if you have language that's different, there must be a language organ in the brain. That, of course, is not the way evolution worked. Dinosaurs evolved, and the organs evolved so that they had feathers, and apparently one of the reasons feathers were favored was because for temperature, to regulate temperature. And as the dinosaurs evolved, they finally had enough feathers that one day they were able to fly. But the flying, it's not like one day they didn't have wings and the next day suddenly wings appeared and they could fly. No, it was a very slow process. So in fact, a desirable account of the origins of language must take all this into account. It must recognize that language is singular, but it must also reject, in order to be in harmony with biological evolution, it must reject extraordinary events like the brain suddenly growing a language organ. And it must show how a continuous path of evolutionary change could have produced something so special as language, but also other things that are special for humans. Again, religion, art, mathematics, technology, and so on. Okay, so this is what we need for, and again, this is on your handout. I will not belabor it. But I will add one more thing. What makes human language, for example, totally different, actually, from even some language you can teach to chimpanzees. To chimpanzees, you can teach about 200 frames. That's already, pretty good. So you can teach them 200 words, and they know, like in the form of chips or in the form of signs, and they know that each one of those chips corresponds to a particular frame, like drinking or eating or fighting or whatever. They can learn the frames. But humans have language that is equipotential, that can be where you can use the frame in order for something new to happen. So we don't limit our universe to 200 frames. We can have literally hundreds of thousands of frames. And when new events come along, we can talk about them with language. How do we do that? We use double scope blending. For example, when people invent, the computer virus, and we need to talk about it, we use another domain, the domain of viruses that are harmful and so on, and we blend the virus domain that we already know with double scope. We blend it with the new discoveries about computers, and we get an emergent notion of computer virus. And this is the way that as humans, we have language that is equipotential. What does equipotential mean? It means it has potential equally for anything. It means anything new that happens, you can find a way to talk about it. So that's the big difference between, primates who learn a little bit of language to refer to frames, and humans who, when they're 1.5 years old, they can already talk about everything that happens to them. Okay? A very, very big difference. This equipotentiality of language is only possible because we have the double scope blending. If we had only framing, then when something new happens, we would not have a frame for it, and therefore we would not have language for it. But with double scope blending, we can use old language in an old frame, blend the old frame with the new events, and use the same old language in a way that will now fit the new frame. And if you look at the evolution of language, this is the way it happens over and over and over again. Okay, so given that, we can now put forward an account of the origins of language that meets all the conditions that I talked about before. Because we can now remember that the blending evolved on a gradient, on a continuum of small differences. And you had sort of prototypical cases were the simplex and the mirror and the single scope and the double scope. But in between, you've got all kinds of intermediate cases. So the natural assumption here is that biologically, the brain, just like the bathtub was filling up slowly with water, the brain very slowly, moved up the level of the gradient of types of blending. But when it was at any of the levels like single scope, mirror, or simplex, it could not produce equipotentiality. And in the domains of art and religion, it could not produce cognitive fluidity, where you have like animals and being humans at the same time and becoming spirits. So it's only when very slowly and continuously the stage of double scope blending was reached, that's when, just like the bathtub overflowing, suddenly there was the capacity to reach the equipotentiality in the domain of language, but also in the domain of religion, in the domain of science, in the domain of art. So this hypothesis explains why there are no fossils of language, there are no earlier simpler languages, because they would not have been useful. It's not useful to have only 200 frames when the world has hundreds of thousands of frames. Remember, the chimpanzees have brains that know thousands of frames in their head. The new ones, they conceptualize, but they're not able to have a language that would fit the new frames because they don't have double scope blending. So that's, in a nutshell, that is the hypothesis that we propose, and that meets all these conditions. Very progressive evolution, but also the singularity of the phenomenon and the explanation of why language, art, science, and so on appear together and appear very suddenly, because behind the scenes in the evolution of the brain, there is the evolution of blending, which finally reaches the double scope level that is needed for all these human singularities. Notice all this doesn't mean that humans are better or anything. We like the things that we do. We like painting, we like art, we like all of that as humans. It doesn't mean that they're good or bad. Stephen Mithun, for example, points out that when you have this cognitive fluidity, that's also how you are able to do very bad things, like treat people as merchandise for concentration camps where you kill them, okay? That also demands double scope blending. So there are admirable human activities that demand double scope blending, and there are also very hideous criminal activities that humans do that demand double scope blending. So here we're not saying because you do blending better, you're a better species. Alas, no, that's not, probably not the case. But what we do explain, what we do account for, is actually why language and art and religion and technology would suddenly explode around, again, 40,000 years ago. And I think that brings me to the conclusion of what I wanted to say. So thank you very much.